we'll see about epimerization. Epimerization is a very important concept, and just a recap which I've already done in the previous video. When you compare the two isomers, only the configuration in one of the asymmetric center will vary. So for example, when you take D-glucose and D-mannose, the carbon in the first 6, the second carbon and atom alone will change, will have a changed configuration when you compare D-glucose and D-mannose. Therefore, it is C2 epimer. Therefore, the second carbon atom of D-glucose and D-mannose will have different configuration. So, if the configuration in one of the carbon atom changes, then we call this as epimers. So, explanation of the reaction. When you consider this particular glucose, you know how to go about it. So, OH, OH, HOH, CH2OH, CHO. The same glucose, I have written it here. So, the glucose, what happens when in the presence of a base, that is NaOH solution. Because NaOH, you all know it is kind of tablet, it will be there. Therefore, it has to be dissolved in water. So, I have considered the aqueous solution. Therefore, I have written NaOH as well as water. So, when I just take the aqueous solution of NaOH, in the presence of a base, what will happen? This H plus ion will get abstracted. OH minus will take away this H plus. As a result, the bond will be transferred to this. It will become minus. This will be transferred to this. Therefore, this will become minus. That's what I have done it here. This will become minus. The minus bond, I have written it in the form of double bond. Either you can write as a double bond or a minus. Now, this when you consider, the remaining atoms will remain the same. OH, OH, H. So, OH will have H, OH will have H, H will have OH. The remaining things are the same. So, when you consider this, I am getting this particular product. So, again this will get transferred and becomes a double bond O. And then what happens? This particular becomes sp2 hybridized. If you look at this, this becomes planar. So, when this becomes planar, it becomes sp2 hybridized. As a result, what happened? H plus attack. This H plus from water can attack from both the sides. So, when it attacks from both the sides above or below the plane, it will give rise to two structures. It is the same as we have seen in the case of a fructose. This particular intermediate, because of the shifting of bonds, leads to sp2 hybridization. Remember children, whenever you consider sp2 hybridized, the molecule becomes planar and the planar molecule will be like this. Therefore, the one will be above the plane, the other one will be below the plane. So, the attack will be either from above or from below when you have sp2 hybridized orbital. As a result, what happened? H plus from water will attack this from above or below the plane, leading to these two structures. What is the first one? We have, when I complete it, it will become OH, OH, H. Then H, H, OH, the usual way. But here we have OH, H, 1. Because of the attack, okay, either from above or below, it gives rise to 2. Look at the other one, the same structure only, OH, OH, H, 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 OH. But what is the difference? Because of the attack which is from below, this will become OH on the left and H is on the right. Therefore, the difference is only in the second carbon atom. This epimerization occurs with glucose in the presence of a base because of the sp2 hybridized carbon in the middle due to the shifting of bonds leads to the formation of D-glucose and D-mannose, where the carbon atoms first remains the same, then 3, 4, 5, 6 remains the same. So, where is the difference here? The difference occurs only with the second carbon atom. The second carbon atom alone shows the difference. Therefore, they are epimers. So, D-glucose and D-mannose are epimers. Since they differ in C2 configuration, they are known as C2 epimers. They differ in C2 configuration. As a result, they are called C2 epimers. If they differ in 3, similarly for something else, it's C3 epimers. If they differ in the fourth carbon atom configuration, we call that C4 epimers. Like this, it will go on. So, normally when you consider glucose, it is reduced by ammoniacal silver nitrate, which we normally call it as tolerance reagent. So tolerance reagent can reduce aldehydes. So since glucose is an aldehydic group, it will reduce the glucose. It's a known fact. But fructose will also be reduced by this. Fructose is also giving positive test. Why? Sometimes the question may be like this. Maybe in the competitive examination you can come across this kind of questions. What is expected? Whenever you have the aldehyde group, it will answer positive for tolerance reagent. But fructose also answers positive. Why? Reason is enediol isomerism. I am not going in detail about this. When you study organic more, you will come to know about it. But the reason is enediol isomerism. So what I have considered here is the normal glucose once again. So OH, OH, H, 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 OH. Okay, the second and the presence of NaOH, we are getting an intermediate. I told you, the same sp2 hybridized. I have shown it here. So this what happens in the presence of water, this OH minus will take away this H what is present here. As a result, there will be a shifting of bonds and leading to the formation of this particular structure. So OH, OH, H, the three will remain the same. Okay, and this leads to the formation of this CH2, COH, C double bond O, then all the things are same. Actually, we started with glucose. We have got the intermediate as we have got here. And because of the shifting of bonds and abstraction of a proton from the second carbon atom, it forms fructose. So, glucose leading to the structure of fructose in the presence of this particular NaOH. You can ask me the question. Ma'am, you told tolerance reagent and suddenly why you are talking about NaOH? Do you know the reason why? Because tolerance reagent is prepared only in the basic medium. It is prepared by taking NaOH solution first and then you have to dissolve this silver nitrate in NaOH and then you have to add ammonia. Only this is called tolerance reagent. So, in the presence of once you take this NaOH, this particular intermediate with sp2 hybridization occur and as a result what happens? The water molecule will abstract a proton from this and removed as water and the H will attack because of the shifting of bonds and give rise to fructose. That's why fructose answers positively. Is that clear, students? The same thing once again, but because of the addition of NaOH in tolerance reagent preparation, it will form fructose in the end. Therefore, it will answer for fructose. Then Horvath projection. So Horvath projection is nothing but we are writing the open chain form in normally open chain. What is open chain? Immediately we think of the Fisher projection formula. Then in Horvath projection, the open chain is getting converted into the cyclic one. So how to write the cyclic structures for this Fisher projection representation of this glucose and fructose. So glucose, you know already how to go about it. CHO at the top, CH2O at the bottom, then OH, OH, H, OH. So accordingly this will become H, H, OH, H. This is glucose. So when you write this, write down. Normally we use the word write down. So when you write down, you consider this way. Right, that is I consider this right as right, then down as downside. So when OH is on the right, it is downside. When OH on the left, it is upside. So to remember it better, hint you have to remember here is write down. So when you consider write down, consider right as right and then down as downside. Therefore, when OH is on the right, it is downside OH. And OH is on the left, then it is upside. So in cyclic structure, these two are to be remembered well. So down normally, what is down? Below the plane, dashed lines. Up is wedge. Okay, that is for your recap. That's all. Therefore, when you consider the structure, what is the first carbon atom? CHO. What is the first carbon atom? CHO. That's what I have written it. Then second carbon atom, third carbon atom, fourth carbon atom, fifth carbon atom comes as a cycle like this. Now the last one is with CH2OH. See what happens here. This is carbonyl. This carbonyl group is highly polar. Therefore, this gets shifted here. It will become minus. And then you know already oxygen has two lone pairs of electron. So because of this shifting, the lone pair of it becomes positive. When the bond is shifted towards oxygen, carbon becomes positive. So the lone pair of electrons here on oxygen atom will connect this carbon with oxygen and completes a ring. Is that clear, students? Therefore, CHO is the first carbon. Then continuously I am drawing that is second, third, fourth, fifth. But the sixth one as CH2OH. This carbon is this. But when you consider this carbonyl group, since it's highly polar, what happens? That will be shifted here. As a result, it becomes minus, carbon becomes plus. Then this lone pair of electrons which are on oxygen, this be given to carbon and forms a bond. As a result, this will become positive. So to neutralize this, what will happen? The H will be removed as H plus, and as a result, we get a ring. So O alone will remain and H plus will be transferred. So as a result, we get this structure. So when you consider the structure, this is on the right side. Right is down. So I have written down. So the other is automatically up. Similarly, when the second side, it is left. Left means what? Upside. So it is upside, and all the things I have written accordingly. Is that clear? Therefore, depending on the left is upside and right downside in the structure of Fisher projection, we are just writing all this cyclic structure. So once you have done that, this is alpha glucose. There is one more anomer. I'll tell you what the anomer is. We call this as beta glucose. Do you know what is the difference? The same here, but this HOH group will be the other way around. It will be present here. H is here, H will be down here. OH is down here, that will be here up. Therefore, that is the only difference between alpha and beta glucose. Both these are cyclic structure. So we have got it from Fisher projection, and there is a shifting of carbonyl bond. As a result, carbon gets a positive charge, and to neutralize this, a lone pair of electrons on oxygen atom in OH group comes and completes a ring. And then because of the positive charge created here, then what happened? The bond here between H and O, the bond will be transferred to this to neutralize this, and H is removed. Therefore, we have this bond. And this structure and this structures are called anomers, because the only difference here is this position of H and OH in the cyclic ring. So in alpha glucose, OH group and CH2OH group. What is this? This OH group and CH2OH group. One is down, the other one is up. Therefore, up, down. I have written up, down. Here it is down, here it is up. Therefore, up, down means it is trans. Up, down means it's a trans structure. Then beta glucose, this CH2OH you consider and this OH you consider, both are up. Therefore, both are up. Therefore, this is cis. Therefore, these two structures differ only by this, that is H and OH. And when you compare the OH group of this carbon, first carbon with the sixth carbon atom, this is trans because one is up, the other one is down. But in the beta glucose form, when you compare the OH group in the sixth carbon atom and in the first carbon atom here, we can see this, they both are up. Therefore, we can say this is cis. And beta glucose, the cis form, is most stable one, because you'll learn all chair form, boat form. I'm not going in detail now. But when you consider one of the forms as chair form, then all the OH group will be in the equatorial position. One will be in axial and another one will be equatorial. So the equatorial position, because of the position of OH in the equatorial position, this chair form becomes more stable in the cis form. But remember, for the time being, cis is more stable than trans. Then when you consider alpha glucose and beta glucose as anomers, I mentioned here itself, alpha and beta are anomers. So what is this anomeric form? Anomeric carbon is the one which is different from other carbon atoms. So anomeric carbon, if you consider this carbon atoms, this particular carbon in the first carbon is different from the rest, and therefore this is the anomeric carbon in glucose. Therefore anomeric carbon is the one which is different from other carbon atoms. Therefore I pointed out the first carbon atom in glucose is anomeric carbon. In D-glucose, first carbon atom is different from the rest, and therefore this is a anomeric carbon. An epimer is a stereoisomer that is different in configuration at any single carbon atom. Therefore, an anomer is an epimer. Epimer, you know, which differ in one carbon atom configuration. An anomer is an epimer at the hemiacetal or hemiketol carbon in a cyclic saccharide. Cyclic saccharide, we come across the word hemiketol and hemiacetal, which is a kind of cyclic form, and you learn it little better in the coming classes. Therefore, this anomer is an epimer at the hemiacetal or hemiketol carbon. So, to make it simple, when a molecule like glucose converts to a cyclic form, it generates a new chiral center at C1. Anomers or epimers that differ in configuration only at the anomeric carbon. So, if the configuration differs only at the anomeric carbon, then we call this as anomers. I just make the point clear. Hemiacetal and hemiketol, if you find for the time being very difficult, look at this definition. When a molecule like glucose getting converted to a cyclic form, it generates a new chiral center at C1. So, the anomers are the epimers that differ in the configuration only at the anomeric carbon. Which is the anomeric carbon I told? The first carbon. So, first carbon, they differ in the configuration. Here OH is down, here OH is up. Therefore, this particular first carbon atom in glucose which differ in the cyclic form with respect to the configuration, we call this as anomeric carbon. CHO is the first carbon. Therefore, the configuration in the first carbon in both the cyclic form differ. Therefore, this is called the anomeric carbon, and therefore alpha and beta glucose are called anomers. Okay. Then another important word you should know is mutarotation. What is mutarotation? It is a change in the optical rotation due to the change in equilibrium between two anomers. What are the two anomers you have? This alpha and beta. So, alpha and beta glucose, when they are in equilibrium, the change in optical rotation of these two structures, nothing but mutarotation. So, remember students, mutarotation is nothing but the change in the optical rotation of anomers. Therefore, alpha glucose you take separately, beta glucose you take separately. Optical rotation to be plus 112.2 degree for alpha glucose and plus 18.7 degree for beta glucose. When you dissolve them separately in water, alpha glucose in water and beta glucose in water, the optical rotation of both change to be the same value plus 52.7 degree. That is from 112.2 to plus 52.7 and plus 18.7 to 52.7. And when you take a mixer and dissolve it in water, that will also change to 52.7. So, this is called the mutarotation. When you take separately or a mixer, both will lead to this. Therefore, the reason for this is when you take them separately, there is a ring opening occurs due to the formation of aldehyde. When you take alpha glucose and put it in water or beta glucose put it in water, both will form the aldehyde. Whenever they form aldehyde, the cyclic ring opens. The cyclic ring opens. Therefore, because of the open chain formation, what happened? They are in equilibrium with alpha glucose and beta glucose. This is for the percentage of 0.02 and this is 26%. Beta is 74. Why beta is more? Because it is more stable. Because of the stability, that is more. Okay. So, when you take this equilibrium, which is with the open chain form of alpha glucose and beta glucose, they are actually, first what does it form? When you dissolve it in water, aldehyde is formed. When the aldehyde is formed, it forms an open chain. So, open chain is in equilibrium with alpha glucose and beta glucose. As a result, what happens? The mutarotation changes to a constant value of 52.7. Is that clear? So similarly, when you want to disturb the equilibrium, you can do any one of the reactions like mild oxidation. So mild oxidation, what happened? The open chain form aldehyde contains will get converted into COOH. Once it is converted into COOH, what happens? Because of the conversion, the open chain of aldehyde to acid, this equilibrium will be disturbed. So once the equilibrium is disturbed, according to Le-Chatelet's, either this will be shifted to this or this according to the reaction what you consider. So you have to apply the Le-Chatelet's principle. Is that clear, students? Mutarotation is mainly because of the equilibrium mixture between the open chain form of aldehyde which is formed on treatment with water with alpha glucose and beta glucose separately. But the equilibrium will be shifted according to the reaction. Is that clear, students? Yes? Thank you.